Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 2, Random Variable and Discrete Probability Distribution, brought to you by Vitan Sir. Hello guys, in the last tutorial which we discussed, I completed some final illustrations related with the binomial distribution. Now in this tutorial, I'm going to start and conclude with the exercise 2.2. Okay, so this is the last exercise of the chapter, so probably this is going to be the last tutorial of the chapter itself. Okay, let's start. There are only 5 questions and they are quite interesting. Okay, now the first question we have. For a symmetrical binomial distribution with n is equal to 8, find p x is less than equal to 1. Now the question itself gives you many details. First of all, the n is 8, but our parameters are n and p, and we actually are not given p here. But if you read the question properly, for a symmetrical binomial distribution. Now from the characteristics of the binomial variable, if you remember, the symmetry means that p must be equal to 1 upon 2. So because this is a symmetrical distribution, the value of the p will be 1 upon 2 from the characteristics. And if p is 1 upon 2, that means q will also be 1 upon 2. Okay, so p is 1 upon 2, q is also 1 upon 2, and we know that n is 8, and what we need here is x less than equal to 1. Now if we take x as less than equal to 1, it will be just 0 and 1, because anything less than 1 is 0. So we have the options 0 and 1, so we will just put that 0 and 1 into the equation. Ncx p raised to x q raised to n minus x. Now n is 8, so 8 is 0, 1 upon 2 raised to 0, and 1 upon 2 raised to 8 minus 0, plus 8c1, 1 upon 2 raised to 1, and 1 upon 2 raised to 8 minus 1. Okay, so that's how we are going to roll here. Let's put the values into, let's simplify this. 8c0 is 1, anything raised to 0 is also 1, and 1 upon 2 raised to 8. Then hc1 is 8, 1 upon 2 raised to 1 is 1 upon 2, and 8 minus 1 is 7, so 1 upon 2 raised to 7. Now you must know the powers here. 1 upon 2 raised to 8 is 1 upon 256, and 8 into 1 upon 2 into 1 upon 128. Simplifying this, we will get 1 upon 256 plus 8 upon 256. So because the denominators are same, we get 9 upon 256 as our answer. So for a symmetrical binomial distribution with n is equal to 8, probability of x less than equal to 1 is 9 upon 256. So that's your answer. Okay, write it down and let's move forward. Okay, the second question. Mean of a binomial distribution is 5. Now mean is np, so np is 5, and its variance is equal to its probability of success. We know that variance is npq and probability of success is p, so basically npq is equal to p. We have to find the parameters. Now parameters are n and p, so we have to calculate n and p first, and then find the probability of event of getting none of the failures for this distribution. That we will get to later. Let's start. NP, that is mean, is 5. We have variance is equal to success, that means NPQ is equal to P. So we also know that Q is variance upon mean, that is NPQ upon NP. Now NPQ is P and NP is 5, so it will look something like this. Q is equal to P upon 5. Okay, I have replaced NPQ with P and NP with 5. Now I am going to change the side of 5 to Q, so 5q will be p in the place of q. I am writing 1 minus p. So 5 into 1 minus p is equal to p. When I open the bracket of 1 minus p, I get 5 minus 5p is equal to p. Now this negative 5p, if I change the side to the opposite, it will become positive. So 5 will be equal to p plus 5p, that is 6p. And when I take 6 into the division of 5, it becomes p is equal to 5 upon 6. So that's my first parameter, that is probability of success 5 upon 6. Next, I can easily calculate q, that is 1 minus 5 upon 6, 1 upon 6. Now I have NP as 5 and P is 5 upon 6. So I will put the P value into the NP equation. So N into 5 upon 6 is equal to 5. I will take this 5 upon 6 on the opposite side. It will become inverse. So that would be N is equal to 5 into 6 upon 5. 5 in the numerator, 5 in the denominator will be cancelled. I will get N is equal to 6. So my two parameters are P 5 upon 6 and 6. Now I need all the successes because I don't have any failures. So all the success means N is equal to 6. So X will also be 6. 66, 5 upon 6 raised to 6, 1 upon 6 raised to 6 minus 6. Now 66 is 1, 5 upon 6 raised to 6 is 15,625 upon 46,656, and 6 minus 6 is 0. So 1 upon 6 raised to 0 is 1. So your final answer will be 15,625 divided by 46,656. Okay, so just glance at the question here and then write it down in your notebooks. Don't forget to do that. In the case of any queries, you can always contact me. Moving on to the third question. A person has kept 4 cars to run on rent. The probability that any car is rented during the day is 0.6. Find the probability that more than one but less than 4 cars are rented during the day. Now here the question is 4 cars are kept on a rate, so total outcomes n is 4. Now the probability that car is rented during the day is 0.6, so naturally my probability of success, that is P, will be 0.6. So naturally car is not rented, that is failure is 1 minus 0.6, 0.4. Now what I need to here calculate here is more than 1 but less than 4 cars. Now my formula is NCX P raised to X Q raised to N minus X. So I will write that more than 1 but less than 4. So value of X is between 1 and 4. It is not equal to 1, not equal to 4. So there are only two values which are between 1 and 4, that is 2 and 3. So I need to calculate my probabilities for P2 and P3 and add them up. P2 will be, because n is 4, 4C2 0.6 raised to 2 0.4 raised to 4 minus 2, and 3 will be 4C3 0.6 raised to 3 0.4 raised to 4 minus 3. Now 4C2 is 6, 0.6 raised to 2 is 0.36, and 0.4 raised to 4 minus 2 is 2, so 0.4 raised to 2 is 0.16. 4C3 is 4, 0.6 raised to 3 is 0.216, and 4 minus 3 is 1, so 0.4 raised to 1 is zero point 0.4. Now just multiply them first, 0.3456 plus 0.3456, and when you add them up, you get your final answer 0.6912. So the probability that more than 1 but less than 4 cars are rented during the day is 0.6912. Simple as that. Okay, let's move forward. Question number 4. There are 200 farms in a taluka. Okay, pretty Indian. Among the bore wells made in these 200 farms of the taluka, salted water is found in 20 farms. Now this data is given as our probabilities directly, that out of 200 farms, 20 farms are found with the salted water. That means our standard success and failure probability we have to calculate from that. Find the probability of event of not getting salted water. Okay, in the question the 20 farms are given with the salted water, but we are supposed to calculate not getting a salted water in 3 out of 5 randomly selected farms in the taluka. Now that means our success is not getting a salted water. So if we get a salted water, that becomes our failure. So this 20 out of 200 farms, that we have to find the probability for not getting salted water, and the success is not getting salted water, and that means failure is getting the salted water. So we are getting salted water in 20 farms out of 200 farms. So getting salted water is failure, that is 20 upon 200, that is 0.1. So if we don't want to get a salted water, that is our success, that is P 1 minus 0.1 0.9. Okay, so I hope you guys got it properly. We are getting salted water in 20 farms out of 200 farms, that's a failure. So 20 upon 200, the probability is 0.1. Not getting salted water, that's a success. So 1 minus failure, 1 minus 0.1 0.9. Now we have selected 5 farms and we are supposed to not get salted water in 3 of the farms. Let's see how we can run it. The formula is NCX p raised to x q raised to n minus x, and we have to put 3 into this equation here. So 5c3 p raised to 3 q raised to 5 minus 3. Now 5c3 is 10, p is 0.9 raised to 3, and 5 minus 3 is 2, so 0.1 raised to 2. My success is not getting salted water, that is 0.9, and getting salted water is failure, that is 0.1. Now 0.9 cube is 0.729 and 0.1 square is 0.01. So when you multiply all of them together, you get 0.0729. So the probability that you will not get salted water in 3 out of 5 randomly selected farms in the taluka is 0.00729. Okay, so that's your answer here. The probability of not getting 3 farms with salted water out of the 5 farms. Okay, the problem here, why this probability is so small, the problem here is that because you are assuming that out of 5 selected farm you will get 2 farms with the salted water, and that probability is very small, and so that's the reason you get this small probability. Now moving on to the final question of this exercise and this tutorial and this chapter. Fifth question. An example is given to 6 students to solve. The probability of getting correct solution of the problem by any student, that means doesn't matter who gets the correct answer, the probability is same for all the students, that is 0.6. Students are trying to solve the problem independently, that means doesn't matter who solves it, no one depends on each other. Find the probability of getting correct solution by only 2 out of 6 students. A pretty simplistic question. Okay, we only have to get solution right by 2 students, not less than 2, not more than 2, not at least 2, not at the most 2, just 2 students. Okay, first of all, getting the example, the answer correct is solution p 0.6. That means similarly not getting it correct, that is getting it wrong, that is failure, 1 minus 0.6 0.4. And also we know that out of 6 students we have to get 2 students to get the right answer, so x is 2. Putting all these things in our equation of NCX p raised to x q raised to n minus x, we get P2, that is 62 p raised to 2 q raised to 6 minus 2, and putting the values, P2 is 15, 62 is 15 into 0.6 raised to 2.4 raised to 4. 15 into 0.36 into 0.0256. When you solve this, you get 0.1382. So my dear friends, that's your answer. Okay, so the probability that only two students get the correct answer out of the 6 students is 0.1382. Okay, so with this I end my chapter here, and because I am ending my chapter, I am going to write the end, not the end, but just end. The end will be when my whole syllabus is over. So thank you very much for being with me throughout this chapter, and of course the previous chapters if you have watched them. If you have not, in the next stream you can just go to any of my playlist of 11th or 12th or 10th SS. These are the 3 subjects I am teaching right now. Thank you very much for watching this tutorial. Like my videos, subscribe to my channel, share it with your friends, and put comments in the section below if you have any queries or comments, or you can just praise me if you want. Thank you very much, and I will see you in my next chapter. Wait for that. Okay, welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics, and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.